A financial services organization manages a global product and collects customer survey data. To process this data, the company is deploying an analytical environment using Amazon EMR. The project involves three user roles: an administrator who manages EMR clusters, a data engineer who handles ETL processes, and a data analyst who performs query operations.
The organization requires a solution that enforces the principle of least privilege, limits deployments strictly to authorized and pre-approved configurations, and ensures that every created resource includes specific mandatory tags. Which approach fulfills these governance requirements? Option A: create IAM roles for each user persona and attach identity-based policies. Use AWS config rules to monitor for non-compliant resources and trigger manual remediation.
Option B: configure Kerberos-based authentication on the EMR clusters during initialization, including a custom security configuration. Option C: implement AWS Service Catalog to manage permitted EMR versions, cluster configurations, and access controls for each user persona. Option D: deploy EMR clusters via AWS CloudFormation templates with resource-based policies attached. Use AWS config to flag and report non-compliant buckets and clusters.
This scenario focuses on cloud governance within a multi-user environment. When managing complex services like EMR across different personas, the goal is to balance operational agility with strict adherence to organizational standards. You must consider how to control what resources get built, who is authorized to build them, and how to ensure all infrastructure complies with corporate policies, such as mandatory tagging, from the moment of deployment.
In my view, the correct answer is option C: implementing AWS Service Catalog. This tool is purpose-built for organizations to create, curate, and distribute catalogs of approved IT services. By utilizing Service Catalog, you can define specific EMR versions and configurations, control exactly which user personas have permission to launch these products, and enforce tagging policies automatically through service constraints, ensuring compliance at the point of creation.
Regarding the other options, Option A relies on identity-based policies, which handle access control but do not inherently restrict the infrastructure configurations themselves. Option B focuses on Kerberos, which is useful for securing data access and authentication within an EMR cluster, but it does not govern the actual provisioning process. Finally, while Option D uses CloudFormation for infrastructure as code, it lacks the structured governance and self-service management features provided by Service Catalog. For your exam, remember that when you see requirements for enforcing pre-approved configurations, limiting user deployment options, and ensuring tagging compliance, AWS Service Catalog is often the primary solution for governing infrastructure provisioning. Understanding the distinction between identity access, intra-cluster security, and comprehensive service governance is key to successfully navigating these types of scenario-based questions.